All right, so what we're going to do now is we're going to approach a new way of solving a uniform probability distribution problem. Really, what I'm saying is it's a different kind of problem, okay? So suppose we have a random variable x that is best described by a uniform probability distribution, and the range of the distribution is from 4 up to 13. And so we know that this creates a rectangle along the x-axis, that's what it's creating. We know that the lower end on the x-axis is 4 and the upper end on the x-axis is 13. And so that creates a range of 13 minus 4. It creates a range of 13 minus 4, and 13 minus 4 is 9. And because it creates a range of 9, that means that we know that the height of the density function, which is the top line, so the bottom line here is the x-axis, the top line of this rectangle is the probability density function, the PDF. And we know that in a uniform probability distribution, the PDF is just simply f of x equals 1 over whatever the range is. So that's 1 over 9, okay? So the height of this rectangle is 1/9. The width is 9. And so if we multiply 9 times 1/9, we get a probability of 1. So the area of this rectangle always equals 1. It always equals 1. And that helps us to be able to identify other proportions or probabilities, okay? So we're looking in this question for a proportion of 0.71, okay? So in previous questions, what we were asked is, well, what is the probability that x is less than or equal to a specific number, like let's say, 6.32, okay? And what we did was we simply did 6.32, which is about, let's say right about here, 6.32, and we identified the area of this rectangle right here. And the way that we did that was we would do the height, 1.9, or sorry, 1 over 9. So we would do the height, and then we would multiply that by the width here, which was 6.32 minus 4. So 6.32 minus 4, and we would do this in a calculator, and we would get a number less than 1, and that would be our answer. That's what we did in the last set of videos, in the last set of lessons, okay? Well, what we're doing this time is now we are trying to, let's see here. Let's look at this. It's now asking, it says, find the value of A. Now, this is not 4 as A. This is not A and B A. We're referring to an arbitrary number. A is going to be an arbitrary number between 4 and 13. So somewhere between 4 and 13, there is some number that we're calling A. Now, in a calculus class, we would refer to this by the letter C. But in this statistics class, we're using the letter A. That's really not that important, but just in case there are some calculus folks out there, just know that normally we would have A as the lower number, B as the larger number, and C as a number that is in between. But in this particular question, we're using the letter A as a number in between, okay? And so what this is saying is, find the value of A that makes this statement true. What statement? This statement. We want to know what value of A here would make all probabilities of X less than that number equal to 0.71. So in the previous question, we were given this number and we had to find this number. Now we're being given this number and we have to find this number. And I'm really putting a lot of word and effort into something that may seem like it's really hard to do, but it's actually really easy. As long as we know how to do the previous question, we can very easily do this question. So if you're the kind of person who just says, well, just show me how to do it. Well, I'm about to show you how to do it. So here's what we're going to do. We know that the way we set this up is we do the probability density function, which is 1 over 9. Where did we get the 9? We did 13 minus 4. So step 1, do this number minus this number, and do 1 over that number, times, now normally here, since this is a less than, we know that we're going to subtract the lower number. We're going to subtract 4. Normally we would take this number and put it here, but since this is not a number, we're just going to put an a here. A minus 4. And this is, normally we would be solving for this number, but in this case we're given that number. We're given 0.71. And now we just want to solve this algebraically, okay? Now, I don't recommend distributing the 1/9. Don't do that. That's going to make it harder. Really, you can get rid of this 1/9 completely simply by multiplying by 9. So we're going to multiply by whatever the denominator is on both sides. So we're going to multiply by 9 on both sides. Over here, it's going to cancel, and we're going to have a minus 4 equals. All right, let's go grab a calculator so that we can do this 0.71 times 9. All right, so here we've got the NumWorks online calculator. Now, just know, I don't know if you like the NumWorks calculator. I've used the physical calculator. I like it. It's definitely worth the price. It's just as good as the TI-84 or the TI-83. So if you like the look of it, I recommend maybe buying one if you're going to do a lot of math. So we're going to go OK here, and we're going to do, what did we say, 0.71 times 9, and that gives us 6.39. Okay, so we're going to go back over here, and this is going to be, let's check that again. What did it say? 6.39. So this is 6.39. Okay. And then all we have left to do is add 4 to both sides. Add 4 to both sides, cancel, and we get A is equal to 10.39. And that's our answer. We have found the value of A that makes this true. So A is equal to 10.39. And that means that from 4 up to 10.39, the probability of this uniform probability distribution is 0.71, and that means that from 10.39 up to 13, the probability is going to be the rest of it. It's going to be 0.29, because if we add up this interval of probability, we get 0.71. If we add up this probability, we get 0.29. If we add them together, we get from 4 all the way up to 13, which we know is 1, because all probabilities of the entire interval equal 1. Okay, let's try another example. All right, here's another one. Suppose a random variable x is best described by a uniform probability distribution where the range is 8 up to 25. Okay, so what does that make our probability density function? It's going to be 1 over 25 minus 8. Well, 25 minus 8 is 17, so our probability density function is 1 over 17. This is saying find the value of A that makes this true. X is less than A, okay, so the probability that X less than A would equal 0.19. So we're going to set up our formula here. It's going to be 1/17 times, and since it's a less than, we're going to use this 8 right here. The probability 1/17 of A minus 8 would be equal to 0.19, okay? And so, like I said in the last one we did, the best thing to do here is probably to multiply by 17 to cancel the fraction. So over here, we're going to multiply by 17. So let's go ahead to our calculator and do 0.19 times 17, 0.19 times 17, and that's going to give us 3.23. So bring down A minus 8 is equal to 3.23. And now we'll add 8 to both sides, and we get A is equal to 3.23 plus 8 is equal to 11.23, and that is our final answer.